students, I hope all of you are doing good. Let's start today's chapter, 3D shapes, symmetry and patterns. This is a very interesting chapter. A line which divides a shape of figure into two identical halves is called the, line of symmetry. Number 2, how many lines of symmetry can you find in each of the following English alphabet? Draw and find how many lines of symmetry are there, okay? Solid shape. An object that occupies a space is called a solid. A cricket ball, a pencil, a brick, a playing dice are some of the examples of solid objects. Some solids have plane surfaces while some have curved surfaces. Some solids have both plane and curved surfaces. Cube. The adjacent figure shows a cube. It has 6 plane surfaces called faces, 12 edges and 8 vertices or corners. Each face is square and 12 edges are of equal length. Next is cuboid. This is the figure of cuboid. The adjacent figure is a cuboid. It has 6 plane surfaces, that is 6 faces, 12 edges and 8 vertices. Each face is a rectangle and opposite face are identical, but adjacent faces are non-identical. Identical means same and non-identical means not a same. Okay. The difference between a cube and a cuboid is that in a cube all the 6 faces are identical, means same, but in a cuboid only opposite faces are identical, right? Cylinder. A cylinder has 3 faces, 2 faces are plane and 1 is curved. It has 2 curved edges and no corner, as you can see in the picture. Next is a sphere. The adjacent figure shows a sphere. It has only 1 curved face and no vertex and edges. Next is cone. The adjacent figure shows a cone. It has 1 plane surface, 1 curved surface, that is face, and 1 curved edge and 1 vertex. Okay. Symmetry. In day-to-day life, we see that symmetry is in everything which are around us. The nature has plenty of things having symmetry in their shapes. The leaves, a butterfly, human body, etc. The temples, mosques, gurudwaras and churches have symmetry. Famous monuments, Taj Mahal, Qutub Minar, etc. have symmetry. So we see that many objects or figures have evenly balanced proportion. These types of objects are said to be symmetrical. Symmetry expresses the idea of balance. Line symmetry. The above shapes, as you can see, are equal in size on both sides of dotted line. That is, these shapes are symmetrical about the dotted line. If we fold the figures about the dotted line, we could get 2 equal shapes which will overlap each other. So the dotted line is the axis of symmetry, or we can say that one half of the shape is a mirror image of the other half. If we consider a mirror is kept along dotted line, that is axis of symmetry, the image in the mirror would look exactly like the other half. Example, see, these are the capital letters of English alphabet which are symmetrical about the dotted line or the line of symmetry. Symmetry in the geometrical shapes or designs. See, there is 1 line of symmetry, 2 lines of symmetry, 4 lines of symmetry, and there is no line of symmetry. Okay. Rectangle has 2 lines of symmetry, as you can see. Square has 4 lines of symmetry. Equilateral triangle has 3 lines of symmetry. Only equilateral triangle has 3 lines of symmetry because its 3 sides are equal. And in isosceles triangle, there is only 1 line of symmetry. Scalene triangle, it has no line of symmetry because all 3 sides are unequal. Parallelogram has no line of symmetry. Isosceles trapezium has 1 line of symmetry, and circle, it has infinite number of symmetry. Symmetry in the letters of English alphabet, having vertical and horizontal line of symmetry. So this is vertical line of symmetry, horizontal line of symmetry, horizontal line of symmetry, horizontal line of symmetry. Okay. Horizontal line of symmetry, no symmetry at all, no line of symmetry. Horizontal and vertical, both line of symmetry is there. Okay. Here again in letter I, there is 2 lines of symmetry, vertical and horizontal. No line of symmetry, horizontal line of symmetry, and there is no line of symmetry, right? Here also you can observe which letter has vertical line of symmetry and which letter has horizontal line of symmetry, okay, and which letter has no line of symmetry. Okay. Similarly, we can see symmetry in numerals, that is in numbers. Okay. 0, horizontal and vertical. No line of symmetry, no line of symmetry, there is horizontal line of symmetry. Again, no line of symmetry, no line of symmetry, no line of symmetry, no line of symmetry, and in 8 there are 2 lines of symmetry, horizontal as well as vertical, and in 9 there is no line of symmetry. Patterns. Patterns exist in almost all walks of our life. Example in music, architecture, art, nature, science and maths, etc. When something happens repeatedly again and again, one can say that a pattern exists. Example, patterns of size. See, the size in increasing, and in this case, a size is decreasing. Okay, patterns of number. See the number 0, 2, 4, 6, 8. Starting from 2, each successive number can be obtained by adding 2 to the previous number. Such numbers are called even numbers. Patterns of letters. See this pattern. A, B, A, B, C, A, B, C, D, A, B, C, D, E. Every time one letter is increasing. Okay. Patterns in even and odd numbers. Even numbers. 2, 4, 6, 8, 10, 12, 14, 16. Starting from 2, each successive number can be obtained by adding to the previous number. Means if we add 2 plus 2, we get 4. Then we'll add 2 to 4, we'll get 6. Then we'll add 2 to 6, we'll get 8, and so on. So such numbers are called even numbers, right? Odd numbers. 1, 3, 5, 7, 9, 11, 13, 15. Here also each successive number can be obtained by adding 2 to the previous number. Such numbers are called odd numbers. Let's do the exercise 14.1. Name 2 objects with both plane and curved surfaces. You will write answer of this question. Okay. Number 2, find the missing numbers in the following number pattern. Okay. 1, 2, 4, then 8, 16, then 1, 2, 3, 4. Okay. Now, if you think that we'll add 2, then we'll get the next number. No, this is not. See, we'll multiply by 2. 1 into 2, 2. 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. 16 into 2, 32. Okay. 32 into 2, 64. And then we'll multiply 64 by 2. 64 into 2 is 128. And then 128 into 2 is, you can multiply. Okay. 2 8s are 16. 1 carry. 2 2s are 4 plus 1. 5 and 2 56. Okay. B part 1, 3, 9. 1 into 3 is 3. 3 into 3 is 9. 9 into 3 is 27. Similarly, we will multiply 27 by 3. Then what will you get? This number 81. Okay. Then you will multiply 81 by 3. You will get 243. Then again, you will multiply by 3. What will you get? 729. Right. Next, patterns in blocks. See, pattern is growing. How? We'll add 2. Then we'll get 3 blocks. Then 3 plus 3, 6. Then 6 plus 4, 10 blocks. Then 10 plus 5, how many blocks? 15 blocks. Okay. Growing pattern. Observe the patterns given below and fill in the blanks by identifying the rule. 1 circle, 2, then 3, then 4, then 5. Then how many circles will come here? 6. 1, 2, 3, 4, 5, 6. This is the growing pattern. Means pattern is growing. Similarly, in B and C part also, the pattern is growing. Okay. In all above patterns, we notice that the pattern doesn't repeat itself but keeps on growing. These patterns grow according to the rule. Right, students? Now, you will do practice of the remaining question.